Hello, everybody, and welcome to today's webcast, Debugging MQTT Client Communications with MQTT.fx and HiveMQ Cloud. We're excited to have Jens Deters, founder of Softblade, speaking today. We will kick off in a minute, but before we start, I want to let you know that all participants are muted. You can ask questions during the webcast by clicking on the Q&A button in your control panel. There will also be around 15 minutes Q&A after the presentation in which we will answer your questions. If we can't answer them all, they will be answered on our community forum. And the link will be shared with you afterwards. Additionally, we will also start a quick poll during the Q&A, and we would be very happy if you would give some feedback on this webcast. And also, I want to let you know that this session is recorded and shared with you afterwards. So this is everything you need to know right now, and I guess we can start. So let's hand over to Maggie and Jens.
Okay, great. So thank you, Verena, for introducing this webcast. Let me shortly give you an introduction to myself. So my name is Maggie. I'm a product manager here at HiveMQ. I'm a speaker at conferences and author of many articles about IoT and MQTT. And one of my main responsibilities here at HiveMQ is HiveMQ Cloud. That is our fully managed cloud-native IoT messaging service. So we will hear and also see more of HiveMQ Cloud later, but now I'm very pleased to turn the floor over to today's guest, Jens Deters, with whom I have the honor to hold this talk today. So Jens, the stage is yours.
Yes, thank you. So my name is Jens Deters. And in my daily job, I'm working for an IT consulting and software development company named CodeCentric in Germany. And then also author of MQTT.fx, which is an MQTT testing tool, and which will be, of course, introduced later in this talk. I'm basically focused on cloud native development, cloud infrastructures, architectures, and Industry 4.0 solutions. For sure, also I'm very interested and have some kind of expertise in MQTT protocol. Okay.
Okay, great. So before we dive deeper in today's topic, let me give you a short introduction to the topic itself. So why are we here? And the thing is, we ask our customers what is the one thing or one important thing that is important to you. And the answer was, well, observability is really important to us. So we want to understand what is happening in the system. And I mean, that is clear. So if we think about the systems we create are getting bigger and bigger. So that means we connect millions of devices, and we have multiple customers who are in this scale. So for quite some time now. That is really awesome, but we really want to know what is going on and what is happening here. So observability is one important thing that our customers want to know. And if we think about the future, I mean, now we have a lot of devices to connect, a lot of IoT devices, and this will increase with time. So so more devices will be connected to the internet than humans, actually. So we are actually in this right now, and the number of devices that are connected to the internet will increase immensely. So that is why we are here. And give me a second. Okay. And it really doesn't depend on which vertical you are, or in which use case you have. So if you're in a connected car, or in the industry 4.0, or in logistics or whatever, so devices that are connected to the internet will increase, and that immensely. And you see here a graph where, and those who are often here at our webcasts know this graph, but it shows how immensely those graphs will increase over the years. So we are here at 2021 with 35 or 36 billion devices. And yeah, that will increase over the next 4 years to a number that is incredible. Okay, so, and because we have that immense number of devices that are connected or that want to be connected over the internet, you also need systems or software that support you. So from the first getting started steps, so really connecting one device to each other, sending some messages, etc., up to a hyper-scaling system with millions and billions of devices. And yeah, one software that is really a reliable piece in your whole infrastructure or in your whole architecture is HiveMQ. So HiveMQ is a connectivity and messaging platform designed for the Internet of Things. It's based on the standard IoT protocol, which is MQTT, and they're also compatible to all the MQTT versions. So version 3.1 and also 3.1.1 and 5. And here we have really all the MQTT features that are in the specification. And of course, HiveMQ scales to more than 10 million always-on devices, which is incredible. And yeah, one cool feature that HiveMQ also has is the extension system. So it's pretty easy to connect to all the other systems out there, be it any cloud provider, service, or services like Apache Kafka, Confluent platform, or also databases, for example. So integrating with any other service is easily, or can be easily done with HiveMQ. Another cool thing about HiveMQ is that we have integrated observability and insights, which means our so-called HiveMQ Control Center gives you really the insights that you need to know about what is going on your system. And later you will see the HiveMQ Control Center in live. We will use it. You see what you can do here and how you can interact with HiveMQ to get the observability you need to have about your system. Okay, so but why is this such a good fit? And hopefully the slide. Okay, great. So this is, so why is this really such a good fit? And to answer this question, we have to look into the technical IoT challenges we see among our customers. And one typical IoT challenge we see is scalability. So as in the introduction, you have millions of devices that you want to connect. And that is really a hard problem with common enterprise IT infrastructure so far. So connect concurrently millions of devices isn't an easy problem. And another problem here with scalability is bring the data that those millions of devices are generating to the backend systems, to also already existing enterprise systems, isn't also an easy solvable problem. So that basically means what I want to say is enterprise IT infrastructure is not always suitable for IoT, and you need something here that is really designed for it. A second IoT challenge, there it is instant data delivery. So I think we all know it. We're kind of used to it that if we send a message, the message, yeah, instantly arrives at the other point. So that means end users are really used to it, that message delivery is kind of instant. And that is even more important for critical systems. So real-time communication around the globe is needed here, and that combined with scale is really a huge problem that wants to be solved. And last but not least, unreliable networks. If you think about the IoT device out there somewhere, maybe your car, then it is not always given that you have a stable internet connection. And yeah, in a perfect world, you would have a stable internet connection, but it's not everywhere possible. And yeah, you know, that's something you have to handle with. So connections can be flaky, especially for moving devices. And yeah, that means you really need something that can help you to communicate over unreliable networks. And that's why we need open standards that are really designed for the Internet of Things. And one standard that is especially designed for the Internet of Things is MQTT. Okay. There. So what is MQTT? MQTT is an IoT or IoT messaging protocol that was originally designed for the Internet of Things and especially made for unreliable networks. So here with MQTT, you can really build a system that handles extreme scale and instant data exchange, and yeah, which is just awesome. It is based on a publish-subscribe architecture, and we will have a look into this in the next slide a little bit deeper. And the cool thing about MQTT is that the complexity of the software is at the broker, so the central component here, and all the easy stuff is on the device. So the IoT devices have the easy part about sending them the messages, and the heavy stuff is all done by the MQTT broker, which is, for example, HiveMQ or also HiveMQ Cloud. Okay, and yeah, it originally was designed or built for devices and machines that are really constrained. So that it makes a really lightweight and easy protocol to connect things over the internet. And that was also the reason why it has become a more and more popular protocol for the Internet of Things. Okay, so where is MQTT? Yeah, in this graphic here. So really, it is a lightweight protocol on top of TCP and IP, and implements this publish-subscribe pattern using topics. And just to give you a short refresher, we have the publisher on the right-hand side here in the graphic. That is, in this case, a car that is publishing a message to the broker to a specific or with a specific topic. And the topic in this case is speed. And every other IoT device that is interested in this message can subscribe to the topic speed and get then the message. So it's all about decoupling publisher and subscriber from each other, and yeah, bring there the advantage of scalability, communicating over unreliable networks, etc. So that is really the cool thing here about MQTT. Okay, and with this simplicity and also the lightweight architecture here, it has proven to be the preferred protocol for the Internet of Things. Okay, so and yeah, basically, where can you use MQTT? I mean, basically everywhere where you have push communication, where you need a reliable communication over unreliable networks, where you have constrained devices, where you have low bandwidth and high latency. And for example, if you want to have an industrial message bus. So basically everywhere in the Internet of Things, MQTT is a good fit. Okay, so today's webcast is about debugging MQTT client behavior with HiveMQ Cloud and MQTT.fx. Shortly introduce you to HiveMQ Cloud. HiveMQ Cloud is our fully managed cloud-native IoT messaging service, which is basically a connectivity layer between the devices out there in the internet that are communicating via MQTT with HiveMQ Cloud. HiveMQ Cloud, of course, contains HiveMQ as enterprise MQTT broker inside and takes over the responsibility to connect those devices to all the other cloud vendors, third-party services, etc. So it's really a connectivity layer between the Internet of Things, so the devices, and the big cloud providers here. Okay. So as you design your applications and your systems, it is really crucial that you have tools that you can rely on, that you have tools for your everyday use, and tools that provide you insights into client behavior, into what is going on. And that means you should build your own MQTT toolbox where you have all those tools that you need and that you find really helpful, and that you have then at hand if you need them, if you have a problem that you want to solve. And one tool that you shouldn't miss in your MQTT toolbox is MQTT.fx, an MQTT client test and debugging tool, which graphical user interface, and many more. And with this, I hand over to you, Jens, to introduce us to MQTT.fx and show us how easy it is to debug client behavior with MQTT.fx and HiveMQ Cloud.
Okay, thank you. So I have to get back my control, my screen. Okay, there it is. Yeah, one of these tools for handling MQTT traffic, or yeah, one of these tool kit is MQTT.fx. A short brief introduction into MQTT.fx. So I personally started MQTT.fx, working on a kind of MQTT tool in spring 2014 as a private project. As a Java enthusiast, I wanted to give JavaFX a try, which was a new Java UI toolkit these days. And I also, as an IoT enthusiast, I wanted to give MQTT as a protocol a try. So I put both of these things together and started to create a UI tool, or a graphical user interface for MQTT usage. And my goal was to create an easy-to-use desktop application for MQTT, and also to prove that you are able to build easy-to-use Java, even Java applications, Java UI-based applications. So I created MQTT.fx also with a strong desktop application target. So I wanted to create installers to install a desktop application like any other desktop application on Windows, Mac, or even Linux. And MQTT.fx brings its own Java runtime environment, and it's not necessarily to install system-wide Java runtime environment, because yeah, it's already bundled with the MQTT.fx installer. And around this tool, surprisingly for me, actually, there quickly started a worldwide community around this tool, and yeah, accordingly with the MQTT popularity, more and more MQTT users or interested people are used MQTT.fx, and until today it's used. Yeah, it's more or less a common one of the common MQTT testing tools. It's used in tutorials, in books, in articles, all across the industries, or also around the private smart home and IoT community. And last year, with two of my colleagues, I started a new company called Softblade, and Softblade will take the future responsibility about MQTT.fx, MQTT.fx development, and yeah, go-to-market strategy. So the feature highlights basically about the current version. As I mentioned, there are native installation packages for all platforms, which already integrates all you need for get it installed and get it up and running as a normal desktop application. I recently replaced the Paho MQTT client with the HiveMQ MQTT client. So MQTT.fx will now support all of the features of MQTT version 5. You can handle different broker connections and setup and parameterization with so-called connection profiles. There is a kind of yeah, a topic collector, which makes it easy to collect all the active topics on a broker. Yeah, of course, all the security settings are supported, and there's also a logging console, which helps you to debug what is going on in the background. So by now, the MQTT version 5 support in MQTT.fx provides for publishing of messages the user properties, which can be edited and set for each message. And you also can set the content type of the message payload, which helps MQTT.fx in terms of receiving of the messages to choose the right so-called payload decoder, which is able to decode the received payload automatically with the right payload decoder. Additionally to that, the user properties of the message will be displayed, also the return and reason codes if presented in the message, and yeah, of course, also the content type of the message payload is displayed. So these payload decoders is a plugin interface of MQTT.fx. Payload decoders, which are shipped as presets, are these. So there's a payload decoder for base64 decoding, hex format. There's a pretty format decoder for JSON content. Of course, also a plain text decoder. And I've seen one of the first questions in the Q&A, which I've already seen was about Sparkplug support of MQTT.fx. And by now there is a Sparkplug decoder which is able to decode the received Sparkplug message to for easy reading of the content. And as I mentioned, it's a plugin interface, so you can use this project here, this GitHub project. It's open source, and with implementing these interfaces, the payload decoder interfaces, you are able to write your own payload decoders and pass it to MQTT.fx, the add-on directory, and MQTT.fx will recognize the payload decoders and make it available in MQTT.fx for decoding messages. Okay, now we'll switch to the hands-on part. So first, we will need an up and running MQTT broker. In this case, the HiveMQ broker, which is provided by the HiveMQ Cloud. I've already created a HiveMQ cluster, a broker cluster, which is available at this endpoint, this URL. And we will now use MQTT.fx to connect to that broker. So this is the MQTT.fx UI. So you have a tab for publishing messages. There's a subscribe tab for subscribing. There's also a basic scripting engine, which helps to generate some scripted traffic. There's a tab for displaying the broker status, some kind of brokers, like the Mosquito broker, and also the HiveMQ supports some additional information, some meta information about the broker based on subscribing to certain topics. And there's also a logging console with to display some of the traffic and some more additional information what's going on in the background. So this is the connection profile editor, and I will create a new profile to connect to the HiveMQ cluster in the HiveMQ Cloud. So, HiveMQ Cloud webinar, for instance. We have to look up at the broker address the endpoint, which is has been generated for this cluster here. We have to make sure the right broker port is used, because it's a TLS port. We have to get to the 88883. We have to create a new or choose a unique client ID. For instance, webinar 1234. So username and password should be this. And we will use basic SSL or TLS security. In the general tab, you are able to choose the MQTT version. So, for instance, MQTT 5. And we can also set a last will and testament here. Okay, with all of these settings, we should be able to connect to the HiveMQ cluster. And there are some icons here on the top right corner, which gives you some information about the connection. So it's an MQTT5 broker connection. It's secured with basic authentication. So username and password. Last will and testament is set to this topic, webinar status. There's a log sign here, which shows that it's an encrypted connection, and the green ball shows successful connection. Now we'll subscribe to, for instance, webinar demo topic. Now we are subscribed, and let's publish an hello message to that topic. See, this is the hello message. As a hint, you can detach these per drag and drop these tab to make it easier to see the received messages and also the published message in parallel. So I clicked 5, 2, 3, 7 times, and you will get the received messages here. So I will use a bit more complex payload. Here is some JSON content, which I will also publish to that webinar demo topic, and it's displayed here. And if you want to decode this JSON topic with in a more readable style, you can choose the JSON pretty format decoder here. So now it's formatted in a more readable style. If I publish again, it will switch back because the content type is text plain, and text plain will use the plain text decoder, but you are able to choose the content type for application JSONs, for instance. And if I now publish the message, the content type will be received and will also use the associated payload decoder with that content type. Another concept of MQTT that you might be aware of is the concept of retained messages. If you mark the message as retained when publishing, this message will be stored on the broker as the last known received message, and will automatically published to every new client, every new subscription to that certain topic. So if I send this message as retained, and we will get back and we have a look at the control center of the cluster. You get the information on the cluster that this message, which I have sent recently, is stored on the cluster as a retained message to this topic webinar demo. So back to the MQTT.fx client, if I unsubscribe from this topic and subscribe again, I will automatically receive that retained message from the broker. And if this message was received as retained, it will also be displayed here in the UI. Another look to the HiveMQ control center. So I will get to the clients. I will have a look at the webinar 1234 client. And this is my client connection here, which gives a more detailed information about these connections. So username, password, it's an MQTT5 connection. It's TLS encrypted, and as you've seen when I've created the connection profile, there's also a last will message stored on the HiveMQ cluster with the payload webinar 1, 2, 3, 4 client has died. The concept of last will and testament is that if the client connection is disconnected, the broker will send this message, this payload, to that certain will topic to give you the ability to track whether a client connection has been disconnected. There are some more clients which are connected to this broker right now. So if you have a look on at the bottom of the screen, there are thousands of clients which have been generated by this Swarm script. And all of these clients are also generating MQTT traffic by sending messages. And in terms of that, I want to show you another feature of MQTT.fx. It's the so-called topics collector. So basically, by the protocol definition, you are not able to ask the broker for all existing topics. It's not a standard. But MQTT.fx is able to subscribe to the broker and scan for all active topics. So if I press scan here, the topics collector will start to scan all the active topics which are producing data here, which gives you basically the ability to connect to a broker and see briefly what's going on there. On a broker with a very high traffic and very much used broker, that might be quite a lot of topics which are active. If you once you have collected all the topics, you are able also to subscribe to the topics by double click or by right click, to automatically receive all the traffic which is sent to these topics. Okay, so that's for the MQTT.fx introduction right now. So what's coming soon as the next major feature is Spark plug support. So you've seen there's a decoder for received Spark plug messages, but by now there's no very comfortable way to generate Spark plug messages and send a Spark plug messages in a Spark plug workflow. But what I'm working on for some of the next versions of MQTT.fx is a kind of a Spark plug message editor, which provides an easy to use interface for creating Spark plug messages. So if you want to give MQTT.fx a try, feel free to download at softblade.de and yeah, ask us for a free try license and yeah, give it a try. MQTT.fx is free for private usage, and there's a kind of community license which is available for free. And for commercial usage of MQTT.fx, yeah, get in touch with us and ask for a commercial license.
Okay, and there's something else that I'd like to introduce to you. Some news that we have for you. So you've seen HiveMQ Cloud in this webcast used as MQTT broker here. For those who are new to, or for those who know HiveMQ Cloud already, know that we have a 7-day free trial available for the starter package. But there's something that we have in planning that will be released soon that will give you a free HiveMQ Cloud broker to use up to certain limits, but it will be free for you to use. And yeah, there you can test and play around with MQTT and get started easily. It's yeah, it's really a cool thing to get started, to build proof of concepts, etc. So that will be available very soon. And if you'd like to be informed, if you'd like to be one of the first persons to be informed about this new release, then scan the QR code here in the presentation and sign up with your email address for our newsletter about this new HiveMQ Cloud release.
Okay, so I think we're going over to Q&A, right?
Right.
So I just started the poll, so we would be very pleased if you could answer it. Okay, so let's have a look at the questions. Jens, if you could go one.
Yeah, the first question was, does HiveMQ support Sparkplug MQTT, and how can we test the Sparkplug MQTT using MQTT.fx? Yes, I think I already dropped a few words about that. So debugging received Sparkplug messages. It's already supported by MQTT.fx, and yeah, generating Sparkplug messages. It's on the roadmap.
Great, and also for HiveMQ Cloud, of course, HiveMQ and HiveMQ Cloud fully support Sparkplug, so you can use it as of now without any problems.
Okay, so the next question is, can TLS 1.2 be activated on 1883 port instead of 8883?
So I think the question is about HiveMQ Cloud here. And yeah, what we're doing here, we're using the default MQTT port for MQTT over TLS. So that is the registered port at IANA for secure MQTT. And yeah, that is the reason why we're using here 8883 instead of 1883, because we really want to ensure a secure communication here with HiveMQ Cloud, because that is really important, that no unsecured traffic goes over the internet here.
Okay. So someone asked, this one is for Jens, this will mean that MQTT.fx will become a paid tool?
Yes, for commercial usage, but it's still free and will be free for yeah, for private usage or for the community.
Okay.
I've seen there's also a question about if there's a difference in the feature set between the free available and the commercial version, and until now it isn't, and I think there will be no difference
Okay.
between these two versions. It's just the purpose of usage that. Yeah.
So there is one question. So the next question is just from Ian Butterworth. He just asks SSL, and I assume that he means, does MQTT.fx support SSL?
Yes, it do. But maybe this question is also asked because of you are supposed not to use SSL anymore, I think. So basically, there is an SSL support. You are able to choose the SSL or the TLS version, which is 1.2 by default. But also SSL is still supported. I don't think that anyone will use that. And yeah, it's also TLS version 1.3, which is supported now.
Okay. So the next question is from Carol's Church. How can I change level of quality of service?
If you want to publish a message, you can choose the quality of service which should be used for the published message here. Also, the quality of service can be set for the last will and testament in here.
Okay. Then there is one pretty long questions that I guess we will answer on our community forum, because I'm not quite sure if this is now to be answered here. Let's go with the shorter ones. Will we be okay? You showed version 5.0.5 of MQTT.fx. Can I find 1.7.1 online only? Is there a newer version?
Yes. So the current version is 5.05. Accordingly with support of MQTT5, I choose 5 as the major version, the new major version. The version 1.7.1 is still available at the former download location, because there are a lot of tutorials and articles referring to this download location. So I kept that online by now, and I will add a hint that there's a new download location with a new version at that location soon.
Okay. There is another version about the download. If somebody asks, where can I download a free version of MQTT.fx version 5 for non-commercial use? So I think you already.
Yeah, you can just download the package, and it will prompt you for entering a license key then, which looked like this. And just request the community license from us, and you will get it immediately for university or educational use and so on. Yeah.
Okay. So then there is another question: is the JSON decoder available on the basic MQTT.fx installer?
Yes, it is. It's one of the preset add-ons. It's automatically shipped. Also the preset payload decoders are shipped with the standard installer.
Okay. And one question by Johnston Hall: how do you load the payload decoders? Here.
I think it is described in the README of the payload decoders. So this is the current set of the shipped payload decoders as an open source project.
Maybe we can send the link to the payload decoders within the follow-up.
The link is also on the slide in the slide deck. And there's also a description where to place the payload decoder. So you have to generate basically a zip file, a jar file, which is created by the Gradle build tool, and you have to put it in the accordingly into the add-on folder, and MQTT.fx will scan this directory during the next start and make your custom payload decoders available in the drop-down list.
Okay. I think then, so then we have no open question left. So there's just this one long question. We'll get back to you, Mike Lisenk. Hope that's okay, because I think this long question cannot be answered directly here. So we'll get back to you. Okay. Yeah, I think then we're done. So if you don't have any, okay, so there's just about the link for the HiveMQ Cloud free waiting list. I will share it again within the chat, within the, it should now be shared within the chat. And then, yeah. But I also will share all links regarding the webinar yeah, afterwards with you. So there will be a follow-up. You will get the slides, you will get all links that are relevant, and also you will get the link to the recording. So thank you very much, Jens, for joining us today, and thank you, Maggie, for speaking. So I hope you all enjoyed the session, and we would be very pleased if you would join us in March again. So yeah, thanks everyone, and see you soon. Bye.
Awesome. Thank you. Bye.
Okay, bye-bye.